Now we will start to solve the problem related to the work energy principle. The first problem. As the bracket ABC is slowly rotated, the 6 kg block start to slide towards the spring when theta is 20 degree. The maximum deflection of spring is observed to be 50 mm. Find coefficient of static and kinetic friction. Okay, so this ABC, this bracket is given. Okay, now earlier this bracket was at horizontal position. Okay, when we start to move this bracket, when we start to rotate this bracket, so what happens, when this theta is 20 degree, this 6 kg block will start to move towards the spring. Okay, initially the distance between the spring and the block was 250 mm. Okay, the maximum deflection of spring is observed to be 50 mm. Means what? When this block will strike to the spring, so the deflection, this change in dimension of this spring is observed to be 50 mm. That is maximum. So we need to find the static friction and the kinetic friction. Okay, so we will find that. Now we have seen the concept of angle of repose in the chapter friction. Okay, so what is angle of friction? Angle at which the object will just start to move. Okay, so that angle is called angle of repose. So here theta is 20 degree, which is angle of repose, right? Also we have seen the relation between angle of repose and angle of friction. So what is the relation between the angle of repose is equal to angle of friction? This is the relation between angle of repose and angle of friction, right? So from this, theta is equal to phi, which is equal to 20 degree. So we got angle of friction, that is 20 degree, right? So before moving this block towards the spring, so it is stationary, so we need to find the static friction, right? So what is static friction? So we know static friction is equal to tan phi. Okay, so tan phi is equal to, what is phi? 20, right? So tan 20 is 0.36. So our first answer, that is coefficient of static friction, is 0.36. So this is the first. Now the second thing, we need to calculate the coefficient of kinetic friction, that is mu k, we need to find. Okay, so to find the coefficient of kinetic friction, that is mu k, we need to apply work energy principle between these two positions. Which two position? So this is the initial position, right? And when it is strike to this, that will be the final position. So to understand this, we will try to draw another diagram. Okay, so we'll draw the simple diagram. So consider this is the bracket ABC, right? So which is inclined at 20 degree. Okay, so initial position of the block was, suppose this is the initial position of block, right? Now when angle is 20 degree, it will start to slide. Okay, it will slide and it will compress the spring. Okay, now the length of spring will decrease. Okay, so by how much amount it will decrease? So it is given in the problem, maximum deflection is, what was the maximum deflection? 50 mm. Okay, now what is the distance between the initial position and the final position. Okay, that we need to find. So earlier this distance was given 250, so it is 250 plus the deflection of spring, that is 50. So the distance between this initial and final is now 300 mm, right? So consider this is the position 1 and this is the position 2. Okay, so I will calculate the vertical change in distance. Suppose we need to calculate this vertical change in distance. Okay, so this is 20 degree, this is 20 degree. Okay, this distance is 300 mm and this is h. So h is equal to displacement. How much displacement? 300 mm means 0.3 meter. Okay, into sine this angle 20 degree. Okay, so this is the h. So this distance is up to this one. Okay, this total distance is 300 mm, that is 0.3. Now what are the possible types of force by which work will be done in this? Okay, so the first, as it is moving downwards, so there will be work done by the gravity force. Okay, so it is sliding, so the work done by the friction force. Okay, and here it is spring. Okay, so the work done by the spring force. So these are the three types of forces by which work will be done. So one by one we will write we will calculate the work done by these different forces. So the first is work done by gravity. Work done by the gravity. Okay, so how will write the work done by gravity? So work done from position 1 to 2, here it is mgh. Okay, mgh. So whether it is positive or negative? Positive. Why? Because it is moving downward. It is moving downward, so it is positive. The gravity force is downward and the motion is also downward, that is why it is positive, right? So here what is mass? Here the mass is 6 kg, g is 9.81. okay, and height here it is 0.3 sine 20. Okay, so we will get sine 20 into 0.3 into 6 into 9.81. okay, so we will get work done by the gravity as a 6.03. This is our work done and the unit is Newton meter. Now the second force, that is friction. Work done by frictional force. Okay, we know the work done by frictional force is always negative. Okay, so minus, so as it is moving, so we will write minus fk into the displacement. So our displacement here it is s. So what is fk? It is mu k into n. Okay, and what is s? Mu k and s. Okay, so mu k, that is coefficient of kinetic friction. What is n normal force here? It is mg cos theta. Okay, that is the normal force, and here it is a displacement. So we need to find this mu k. We don't know the mu k. So m is mass is 6, g is 9.81, cos theta is 20, right? And displacement. So what was the displacement? That was 0.3. Okay, So calculate this and you will get the value. So it is cos 20 into 9.81 into 6 into 0.3. So you will get 16.59. Okay, you will get 16.59. Now the third force, that is spring force. Work done by spring force. Work done by spring force. Okay. Now the earlier position of spring was, suppose this was the earlier position. Okay, and due to the compression, suppose this is the final position. Okay, consider this is the equal x1 position and this is the x2. So x1 is suppose initial position 0. So what is the maximum compression here? It is 50. Okay, after the block collide this spring. Okay, block compress this spring, that is 50 mm is the maximum deflection, right? So what is the work done by the spring force? Work done by the spring force is given by 1 by 2 k. K is the stiffness of spring, in bracket x1 square minus x2 square, right? So 1 by 2 stiffness of spring is given, that is 1500 is given. Okay, so x1, consider this is the initial position of spring, which is 0. After this there is a deflection of how much? 50 mm. In meter it is 0.05 meter. Okay, now calculate this and you will get the answer. So 0.05 square into 1500 divided by 2. So it is minus 1.875 Newton meter. So these are the three types of forces by which work is done. That is work done by gravity, work done by the frictional force, work done by spring force. So total work done. So we need to add all these three forces. So the work done by the gravity force is 6.039 minus work done by the frictional force, it is minus 16.59 mu k. Okay, and work done by the spring force, so here it is minus 1.875. Okay, so if you add this you will get 6.039 minus 1.875. So it is 4.164 minus 16.59. Okay, this is the total work done from position 1 to 2. Okay, block position from 1 to 2. Okay, now so kinetic energy, talking about the kinetic energy. So this is the total work done. So we know the relation between work done and energy. Okay, so that is the total work done is change in kinetic energy. So first of all we will find the kinetic energy. Okay, so kinetic energy at position 1. Okay, so if you see at the position 1 the block was at rest, means at this kinetic energy is 0. Now kinetic energy at position 2. So here it was a spring. Okay, when this block compress this spring, so this spring compresses to its maximum, that is 50 mm. Okay, so what happened when spring compress? So all whatever the kinetic energy here, it is all absorbed. So here kinetic energy at position 2 is 0. So total change in kinetic energy is what? Ke2 minus Ke1, here it is 0. So change in kinetic energy is 0. So by work energy principle, total work done. So work done from 1 to 2 is equal to change in kinetic energy, Ke1 minus Ke2 minus Ke1. So what is the work done here? We got 4.164 minus 16.59 mu K, and change in kinetic energy is here 0. So what we'll get here, mu K is equal to 4.164 divided by 16.59. So 4.164 divided by 16.59. So our value, second value, that is mu K, we will get 0.25. Mu K is the coefficient of kinetic friction.